Thank you, Chair. Today my talk is about the ocean typhoon interaction. That means that short time scale interaction between in ocean and atmosphere interaction. The oceans dominating the accumulation of energy in the Earth system and explain more than 90% of the accumulated energy during the last 40 years. And the warming is expected to going on, and heat transferring from to surface to deep layers of water and the ocean, and we expect that circulation will change. This is some summary of some IPCC report, fifth report. And also in IPCC fourth report, there is some description about hurricane. Hurricane intensity intensified since 1970 and correlated with the SST. And hurricane intensity is expected to during the 21st century. This shows that the world ocean heat content, as we expected, it keeps increasing. So over the surface to 2000, also some layer thickness. And recently also Lomich shows that the global ocean heat content is anomalies keep increasing with some yearly oscillation. And our background is that due to heat deposit in this region, we expect that the rapid intensification typhoon in the eddy region of Northwestern Pacific was observed. And for the last 20 years, there was some strong typhoons intensified over some category 3 to category 5. It means so this shows that how it is intensified during some propagation. This shows the latitude, and this shows some wind speed is in knot. And during some 20 to 25 knots, it increased, as you've seen here, that it is increased from over the, for example, over the 1 day, its speed is intensified over 30 knots. We call that is a rapidly intensified typhoon. So we think that this is related to quite some ocean thermal energy. This shows that the residual surface by thermal expansion. And one case for some Philippines is that in this case, it shows that Typhoon Haiyan intensified to category 6. And this map shows that ocean temperature anomaly at 100-meter depth, October 2013, so that it shows that temperature anomaly at the 100-meter depth is showed at 4 degrees, 5 degrees. So during typhoon passage, is quite intensified. So category 1, 2, 3, 4, 5, even category 6. Category 6 means about wind speed is stronger than 80 meters per second. So from this, as well some discussed in the previous talks, this region is the area where the ocean heat is accumulated or concentrated with time. Also, sea level rising in this region is over the 1 centimeter over a year. So it is one of the largely rapidly increasing in terms of sea level rise. So we think that this area at also Northwestern Pacific has some two regions. One is a short-term interaction of typhoon-ocean interaction. One is a long-term interaction, ocean-atmosphere interaction. So in total, we see that the typhoon-ocean-atmosphere interaction in the Northwestern Pacific. This map shows that the annual map of ocean heat content is about 35 kilojoule per square centimeter in the peak case. So, but in case of the strong typhoon of category 4 or 5 is value increased to 100 or 110. So it's annual mean is relatively small, but if we see some short time interval, several days or 1 month, then it increased quite. So our research purpose is that mainly is investigate of typhoon's rapid intensification process through the observation of air interaction. And because the prediction, some forecasting, some numerical model cannot accurately predict such kind of a rapid intensification, so that the investigation typhoon's rapid intensification process through understanding of air interaction and the prediction modeling system of RI typhoons based on some ocean atmospheric coupling, some modeling. We try to understand this, the air-sea interaction in case of typhoon-ocean interaction case. For example, as I mentioned, that we think that mainly our posing, some heat posing is due to warm eddy. It's mainly due to the STCC, the subtropical countercurrent, induced by STCC. So if there is some subtropical current eddies with time changing in the latitude of 20 to 20 or 18 to 22, something like that, that latitude, and then we think that there will be some, if there is no typhoon, there will be some interaction, ocean, warm air and warm eddy interaction will be dominated. But if category 1 or 2, then we expect that a less violent air-sea interaction. But if category 4 and 5, it means that wind speed stronger than 60 meters per second, then we expect a violent air-sea interaction. But there is no report in the world that there is any observation for in this case using bias, because the direct measurement of the using some observation tool is impossible. So yeah, there is some way using to observe by aircraft, but it gives us some snapshot. But we think that there is not enough some data for this in this case. So we expect that from in the Northwestern Pacific there will be one of the some process in the year. So using this, then we should study. We should study this relation between with the times. So during this process, during period, we are going to observe CTD data to know the ocean heat content, and during typhoon passage, we cannot measure using some vessels, so we deploy several automatic instrument, Argo, float, surface drift, and other wave glider or underwater wave glider. And also, we are going to use some numerical modeling for understand the circulation pattern, eddies in this region, Northwestern Pacific region. Also, we are going to study some not short-term, it's a long-term typhoon and STCC eddy in this region. So we are using some global model or some climate-related data to understand the change of the subtropical counter currents driven some eddies. And we also trying to numerical modeling, some experiment to understand the RI mechanism. So as we well know that momentum heat exchange between some sea and typhoon is can represented by the maximum possible wind speed is proportional to heat diffusivity and the drag diffusivity. So if we change this relation or this coefficient from the observation or according to the wind speed and ocean, then it will change. So we think we can expect that this will change. So also in the heat exchange, is recently known that spray effect is important. Also, wave effect is also important in this type of propagation in terms of the frictional effect of during the typhoon passage. This shows that some example of how through this interaction, this typhoon track and typhoon intensity is changed with this short time being. So relatively this short time some air-sea interaction, but 1 or 2 days, even 12 hours, because during this time wind speed is changing quite rapidly. And also, as I mentioned, that with the short time some scale variability, we are also going to study variability long-term study. As the previous talk that there we're going to study some relation of the long-term trend of the typhoon passage. Also using some radio zone data over the all those observation period, we hope that we understand that some signals in relation to some climate, well, even though it is long-term, some related to variables. Also, we are going to have interest in this how typhoon changes in the warm some variability conditions. So our program will start from this year for next 5 years, and we have many cooperation, domestic and some foreign, some research and university. Thank you.
Thank you, Dr. Kang.